All right, so in this video, we're going to be looking at the second fragmentation pattern from alcohols. That's going to be dehydration. The previous video, I went through the alpha cleavage for alcohols. So review that if you want to look at those mechanism arrows. So for dehydration, it's going to be very similar. I'm always going to start with that radical because it's always going to tell me where to look. All right, now, if I'm doing dehydration, that means I'm going to be losing water, right? OH is almost there. I need another hydrogen. And I'm going to be very specific about what hydrogen I'm using, and that's going to be the gamma hydrogen. So the gamma hydrogen is going to be the hydrogen located on a gamma carbon. So the carbon bonded to the alcohol is my alpha position, and then the one next to that's going to be beta, and then I'm going to have gamma. So alpha, beta, gamma. I do see I have a gamma carbon, which means I do have a gamma hydrogen. I actually have two of them here, but I only need one of them to form water. So I'm good to go. If I don't have a gamma carbon, that means I don't have a gamma hydrogen, and I cannot do dehydration. So always check to make sure that you have a gamma hydrogen before you start this. Okay, so let's go ahead and start with those arrows. Like I said, I'm going to start with the radical on the oxygen. Now, it looks a little weird because what I'm going to do is it's just going to be pointing somewhere in midair. Usually, we never let you get away with that, but whenever you're doing radical processes, sometimes you have to do that because you can't just point at an atom. All right, we're going to finish that bond by meeting that arrow with one of the electrons from the carbon-hydrogen bond, and then we're going to put that other radical on the gamma carbon itself. So that's going to complete forming H2O, but I need it to leave. So I actually need to break the bond between the carbon and the oxygen to get water to go away. This is going to be the only arrow in this mechanism that is going to be a double barbed arrow where that oxygen is going to take both of the electrons in the bond. So what I get from this is the following fragment. Well, I know I formed water. Well, water is not charged, nor is it a radical, so my mass spec is not going to care about it. And then what's left is that carbon chain. All right, so this is my carbon chain. Now, I no longer have a functional group, so you would not say anywhere specifically alpha, beta, or gamma. I'm going to write those labels just so you know where everything came from. So, again, you would not normally write these because there's no longer an alcohol to say that's alpha. But this is the alpha carbon. Because it lost those electrons, this is where that positive charge needs to go. And then the gamma, we put an electron on that carbon, so I need to put a radical here. Okay, so that's why I put the labels there so you knew where the radical and the cation came from. It's from where those bonds originally were, okay? Since that is my charged species, this is a weird one because it just so happens it's both my cation and my radical. There's nothing that says that is not allowed, so it's fine. What we're going to do is find that mass to charge ratio for this. So I have 1, 2, 3, 4, 5, 6 carbons. So 6 times 12 is going to be 72. And now I'm going to look at my hydrogens. Okay, I'm going to use the original structure just so I don't lose anything. So I should have 3, 6, 8, 10, 11, and then 12 right here. So I'm getting 12. All right, and then I've lost all of that, so I don't include that. So what I'm getting is 84. So I should have a mass to charge ratio of 84 for a loss of water. Okay, and that's it. That's all I'm going to do for my dehydration. So let's take a look at our mass spec. Just as a reminder, we did expect to see a mass to charge ratio of 87 and 45 from our homolytic cleavage. And do not forget about that molecular ion peak of 102. So let's take a look. All right, I'm going to make it a little bit darker so we can see it. So I have 102, which is my molecular ion peak. Notice that it is very, very small. That is very standard for water because it very much readily breaks apart for that loss of water, that dehydration. So that's pretty normal. With that loss of water, so if I say 102 minus 18, I should get 84. So there's our loss of water peak. I did expect to see 87. That was our alpha cleavage. So here's our alpha cleavage here. And then my other alpha cleavage was 45. All right. So we were able to find all of the fragmentation patterns that we expected to see. Notice again, we are not interpreting every single line in the mass spec. All right, we're just focusing on the ones that will let me know or verify that this is the structure I'm looking for. And that's it for alcohols.